Hey, what's up, everybody? Isaac here, Civil Engineering Academy. Excited to be with you on another fun podcast episode. We're still in the middle of a move, so if you hear kids yelling and stuff happening, it's life. So I'm excited to be with you again on another podcast episode. I have a really awesome guest today, Ricky McLain, who specializes in mass timber. He's a professional engineer, a structural engineer out of Vermont. He works for an awesome company called WoodWorks that provides volunteer information to help any company. If you're designing with wood, they are a resource to you for information. So WoodWorks does great things to help educate people and to help you with your designs. If you are going to use wood in any form, mass timber, glulam, beams, anything of that nature, they're there to help you figure things out. So Ricky does a great job of explaining the popularity of mass timber in the United States. It seems to be doing some sort of hockey stick going on. There's a lot of reasons for that we'll dive into. But if you have any interest in learning about mass timber or learning how to use that in your structural designs, this is going to be a great episode for you. And it's going to be coming up right after this with Ricky McLain. See you in a minute. All right. We are live, rocking and rolling. Ricky, thank you so much for jumping on the Civil Engineering Academy podcast. I appreciate you doing this with me.
Yeah, thanks so much for having me. I appreciate the invite.
Awesome. Well, we're still in the middle of a move over here, and so if we hear crazy noises, I'll just warn the audience. It's probably my kids.
Fair enough.
And homework time. But I always love starting these things, just kind of you explaining your own background and really how you found yourself into not only into the world of civil engineering, but into really what you specialize in. If you could maybe give some background to that would be awesome.
Yeah, for sure. No, I'd love to. So going way back, when I was a kid growing up, I did I really enjoyed building things with my hands, carpentry work. I built, picnic tables and sheds and those types of things. So really kind of building things with my hands was something I liked and did a lot of. In high school, I worked for a car mechanic and really didn't have any idea what I was going to do in the future. So I basically went to my local community college when I graduated high school and said, do you have a car mechanics class? Because that's kind of the only thing I know. Not really thinking much about my other at the time, their car mechanics class was full for the coming year. So then I said, all right, I remember this conversation very well, standing in the kind of the counselor's office, like, what else do you have? I need to enroll in something. And she asked, what else do you like? What are your interests? So I started talking about carpentry. She said, well, we have this new civil engineering. It's a 2-year curriculum associate's degree coming up. Maybe you would be interested in it. There's some construction, there's some surveying. So I said, yeah, I'll give that a try. So really just off of a whim, enrolled there, went there for a year, loved it, transferred to the larger 4-year university in the area. This was in Maine. So I transferred to the University of Maine at Orono, and finished my 4-year degree there and specialized in structural engineering. I family here in Vermont, which is where I'm based now. So Vermont to take a position of consulting firm right out of college. And I was there for about 7 years. We were a small firm. I think we had 12 or 13 people total, some civil engineers, some structural engineers. And that really exposed me to a lot of different project types. We did everything from custom single-family homes. There's a lot of ski areas near us, so a lot of pretty fancy single-family homes, as I'm sure there are near you in Utah. And then some, municipal buildings, fire stations, schools, and all of the above. So I didn't specialize in any one material, like structural material then. But as you alluded to, I've kind of grown into a specialty in mass timber. And that came about through an opportunity. I was approached for a position for WoodWorks, which is where I work now for about 9 years. And the position with WoodWorks was basically to be a part of a team who is a nonprofit funded by the wood industry to be a free resource to architects, structural engineers, contractors, and developers. And maybe we can talk more about specifically what does that mean in a minute. But starting with WoodWorks, it's basically we were focusing on all types of wood construction and still do to this day. So light wood frame construction and heavy and mass timber. But mass timber was really just starting at the time and was really something that interested me. So as kind of I grew in my role with WoodWorks and mass timber was being more and more used in the US, That's really where I started to find this specialty, which is really where I spend most of my day now, is helping on master projects and creating resources for community.
That's awesome. I want to ask, there seems to be a growing popularity with mass timber in the United States. Is that what you're noticing, and how are you playing a big role in that?
Yeah, there definitely is. So I mentioned like about 9.5 years ago is when I joined WoodWorks. So that was fall of 2014. And at that time, there was no recognition of, so the most common mass timber product, maybe just to take a step back for a second, mass timber is a term that's kind of an umbrella term that like a bunch of different products fit into mass timber. Essentially, it's large sections of wood. So mass is short for massive. And so it's a large, massive section, but they're composed together of a number of small pieces of wood. So usually like 2x6 or something like that, commodity lumber products, nailed, screwed, or most commonly glued together to form these large cross sections. So cross-laminated timber, CLT, is one of the mass timber product types. It's probably the most common one right now. So to go back to what I started there was September 2014. At that time, there was no prescriptive recognition in the building code to use CLT as a material. Like that's how new it was. It had started in Europe. Some North American, like Canadian manufacturers started to use it a couple of years prior to that, like 2010, 2011. But even in 2014, there was no prescriptive code recognition for it. So 2015 was the first time that occurred. And then ever since then, we've seen a rapid acceleration of like the number of projects that are using it, the location of those projects. It did start very much focused in the Pacific Northwest. There's still a lot of in Pacific Northwest that it's spread throughout the country. On our website, on the WoodWorks website, we track the number of projects per quarter. We update this project map. And so, yeah, you can see, we kind of call it the hockey stick growth curve, where it was the first 5 years we're growing, but not super fast. And then the past 5 years or so have grown quite rapidly.
And Ricky, what's driving that growth? Why is everybody turning their attention to this?
Yeah, I think it's a combination of things, and it really depends on the owner and what their particular interests are, but also what challenges their project is encountering and how mass timber might help solve them. So it's not a one size fits all. I certainly don't believe that mass timber is the best fit for every project. Some of those reasons are sustainable, reducing the embodied carbon of construction. So mass timber being a renewable resource tends to have a lower embodied carbon than other structural material alternatives. So some people are choosing it because of that. For example, some cities or even just some organizations like colleges or large development companies have declared certain goals that they want to hit with reductions in embodied carbon. So using mass timber is a good way to do that. Mass timber tends to be a faster install process, again, compared to other structural materials. So if you look at the duration of erecting the structure, mass timber might be 25 to 30% faster. So, you're in an area where, or a project where you it's a school or something like that, and you're on this very compressed construction schedule, mass timber might be a way to help you do that. And the reason for that is not because it's timber. The reason is because it's prefabricated. So mass timber components are essentially kits of parts where they go to a job site. Every single mass timber element, whether it's a glue-lam beam or a glue-lam column or a CLT panel or some other component, it's all fabricated for a specific location on a specific job. So that's what they call it, kit of parts, kit of Legos. It goes together quite quickly at the job site because the time has been taken up front to coordinate it and fabricate it in that manner. Tends to be smaller on-site crew sites, usually 9 or so on a job site. Is what you've seen. So in areas where you have very high on-site labor costs, especially in urban centers, the combination of speed of construction and low on-site crew size really helps keep those construction costs down. And then I guess the last one I'd mention is the kind of the financial benefits, kind of long-term financial benefits. So I don't think we would, we talked a minute ago about the growth that we've seen of mass timber. There, things like sustainability, those are all good, but if the financial aspect wasn't there, it would only get so far. So developers are seeing real benefits in using mass timber for things like, because at this point it's still new, you might be building, if you're building a mass timber building, say in Salt Lake, first, the second, or the third mass timber building in the city, you have an advantage where, you might be competing against thousands of multifamily units that are under construction, but if yours is mass timber, it's a differentiated product, right? There's not many like that. So what does that mean? It means you might lease up your building faster. It means you might have longer tenant retention. It means you might, if you're going to sell the building, you might get a higher selling price for the building. So there's some financial benefits that a developer could see, or even like a public developer, like a university project. They're using mass timber projects as sort of their resume to attract students to campuses. So it's a differentiator as well, what it comes down to.
And what about the aesthetics? Because I get this sense that people also love it because it just looks cool.
Yeah, for sure. That's definitely gloss, and probably the is the aesthetics, the look of it, in combination with some of the other things. I mean, that's why it is a differentiated product, right? Because you're exposing it. You save in, installing gypsum. You're not installing gypsum on it because you're leaving it exposed as the ceiling. So certainly the aesthetics is one of the primary reasons for using it.
That's awesome. I'm just curious while we're talking about it, is there any new developments or anything that you're seeing in mass timber, or is just getting more recognition?
Yeah, so a couple of things have happened and are currently happening. So I mentioned like the 2015 code was the first time that mass timber or CLT was recognized just as a building material whatsoever. But at the time, you wanted to build with mass timber, you were perhaps you were for light wood frame construction. So that's 5 stories if it's a multifamily building, 6 stories if it's an office building. That all changed in the 2021 version of the code, the IDC. So in that version of the code, those height limits jumped up from 5/6 stories to now you can go up to 18 stories with mass timber. And we've actually seen several projects do that, plus a little bit more. There's a project in Oakland under construction right now that's 19 stories. And then the tallest mass timber building in the world is completed, and it's in Milwaukee, Wisconsin, and that's 25 stories. It's 19 stories of mass timber over 6 stories of concrete. So one of the biggest areas is just the codes allowing you to do projects. The second is not finalized yet. It's in the works, but it kind of goes hand in hand with this taller concept, and that's the use of timber in tall seismic force resisting systems. So pretty much all of the tall mass timber projects and most of the low and mid-rise mass timber projects are still using something other than mass timber for the wind and seismic force resisting systems. There are some projects that have used like CLT shear walls and a few that have used timber braced frames, but predominantly they're using steel braced frames or concrete shear walls or masonry shear walls or even light wood frame shear walls with plywood or OSB. But last summer of 23, at the University of California, San Diego, they have a large outdoor shake table to see earthquakes and how to take each. So they built a 10-story mass timber structure on this shake table and simulated, it was somewhere between like 1 and 200 different earthquakes with this structure. The results were quite astounding. The minimum amount of damage that occurred and it's all pointing towards what are the seismic response coefficients going to be when this is proposed as an allowable system in a future version of ASCE 7. So those are a couple of the kind of the recent developments that come to mind.
That's awesome. I know there's a ton of benefits to using mass timber. I'm wondering if maybe you could hit just a couple of the reasons why you wouldn't use mass timber in a design for those that may be curious about that.
Yeah, sure. It's a common question because like if you start, mentioning all these benefits, like I've said, you might get the question that, well, what's holding it back? A lot of people ask that question. And like I mentioned earlier, just to recognize that I don't think that mass timber is the best fit for every project. Certainly I'm of the opinion that, use the best material, the most appropriate material for the given application. And that's going to vary based on the project. It's also going to be, a lot of projects will find a sweet spot in using what we call a hybrid approach, which means combine different structural materials. An example could be a project that uses structural steel columns and structural steel beams with CLT floor plates on top. There's some projects that use B with concrete slab that does match. And so I think using the most appropriate material in its place is the first point to make. But in terms of like, what are some reasons to potentially not use it? I would say the most commonly cited one is cost. And there's a bunch of layers to cost, meaning a lot of times mass timber will cost more than the alternatives. In some cases, there will be some initial cost estimates that kind of over predict that cost premium because people aren't familiar with the material. So they might apply contingencies and things like that to make it look like mass timber costs more than it does. But on other projects, it does cost more. So, you have to, if it does cost more and you need to get to a cost neutral project, then either you need to account for some of the things we mentioned earlier, like speed of installation, smaller crew size, less finishes, smaller foundations. See if those things have enough cost savings that will kind of counteract the cost of the structure, meaning like what's the cost of beams, column slabs for one system versus beams, column slabs for the other system. Mass timber is just about always going to be more expensive just based on that. So it really does take a holistic project assessment to see what are the impacts of using mass timber on this project as a whole. It also requires designing it as mass timber from the start, meaning, know what its efficient spans are, know how to design it so that it can be erected quickly. There's a lot that goes into that. So it's a tough question to answer in terms of like, what does mass timber cost quickly? Because it certainly depends. But I think cost is probably the most commonly cited reason that it's not being used now.
Okay. Well, a lot of our audience is obviously civil engineers. If they wanted to maybe dive more into mass timber, what kind of skill set would they need to have, or advice that you would give if they wanted to dive into this particular structural material?
Sure. I think a couple of things that come to mind is, maybe this is a rudimentary one, but I think it's a different way of thinking in terms of like, how are you designing structural materials just in terms of like ASD versus LRFD, allowable stress design. With wood design, this is true for other wood systems too. Wood is generally done on an ASD basis. You don't have to do it that way, but that's just generally how it's done. And that's true for mass timber as well. So, if you've only designed steel or concrete or something, you probably have used LRFD. And brushing up on what is ASD design and how do you do it might be a good place to start. One of the things that's interesting with mass timber is that usually the floor slabs are controlled in terms of like how far can they span by vibration, by walking excitation. And like I know with structural steel, obviously you do that. There's some really good ASCE design guides out there to help with that. That information historically has been lacking. We did WoodWorks backward flow vibration design recently, so that but if you're just used to designing a structure and checking like for bending and deflection and shear, with mass timber, you'll want to kind of get up to speed on the vibration design checks that go into it. And then the third thing I would say is that you're going to rely on external data more than you might think. And what I mean by that is, it's not like you're saying, okay, what's the thickness of my CLT panel, for example? And then what is, how do you calculate a section modulus using that panel? Because mass timber is an orthotropic material, meaning there's layers that run in both directions, it's not a simple calculation to say, what are the properties of that? But don't let that dissuade you, because those properties are actually given in so it's then outside that you go to manufacturer produces PLC. They've had some third-party agency create a product report for them. And then within that product report, you can find what is the bending capacity, what's the shear capacity, what's the stiffness of this panel. So you're basically taking those factors, adjusting them, and using them in your project.
That's fascinating. Bringing that up just made me think of another question about this material type. And are there any misconceptions that may be out there about this material that you hear a lot of that you wish people would have a better understanding about?
Yeah, fire. I would say fire is one of the most common ones. So the first thing is that mass timber is wood. I actually just did a post about this on LinkedIn the other day, and it got a lot of traction so mass timber is wood. Wood is combustible, therefore mass timber is combustible. But it's wood frame material. Those large cross sections of wood that we talked about earlier, it has an inherent fire resistance, meaning in and of itself, if that section is large enough, basically it can provide you a given fire endurance or fire resistance for a period of time. And you can calculate what that period of time is. It's just some simple structural calculations that the engineer can find it's in chapter 16 of the NDS, which is the wood design specification. So within that document, there's some very simple calculations. So you can calculate a 1 or 2 hour fire resistance rating for a given mass timber element. So that's why it's important to recognize that it is combustible. It does behave differently than other wood materials, but in the event of a fire, it can contribute fuel load to a fire. So there's several kind of fire dynamics involved in that, and this is just taking a very simplistic explanation to it. If somebody's interested in diving more, I'd be happy to talk with them or connect them with other resources and materials. But I would say that fire is one of the most commonly misunderstood aspects, because people think it's wood and therefore it's not safe in a fire event.
That makes sense. Yeah, I'm going all the way back to college days, but I remember those calculations in the NDS manual. I took a structural wood class myself. So, yeah, back in the day. So, it's not as worrisome. After I took that course, it kind of opened my mind to mass timber design a little bit as well. But I wanted to bug you a little bit about what you do now with the company you're with, WoodWorks. Could you describe what they do, what the mission is, and you to support it?
Yeah, absolutely. So I mentioned briefly that WoodWorks is a nonprofit organization. We're national, so we're throughout the U.S. Everybody that works for WoodWorks is remote. So we don't have like a central office anywhere. Our goal and mission is to basically accelerate and ease the path for the use of wood in multifamily and commercial construction. So we basically will help and work on any type of project that's using wood primarily as a structural material, other than a single family home. So we're working on a lot of multifamily projects, and then also some higher education, mixed use, commercial, retail, and so on. The wood lumber board is a primary fund funding from USDA, the U.S. Department of Agriculture, Forest Service, as well as the Forestry Innovation Investment, which is a Canadian organization. And then we receive funding from a number of individual wood products manufacturers. So mass timber products manufacturers, light wood frame products manufacturers. Basically what they're funding our program to do is to have a technical staff of experts in wood design, so that when somebody else has a question about designing a project with wood, we're here to be a free resource to them. So we don't function as architect of record or engineer of record on any project, but we work with the people that are those on projects. So, it could be very high level questions like, we've got this 3-story office building. Does the code even allow us to use wood at all in that? We can kind of help them assess very early on code compliance path. But most of the time, the questions are construction type needs to have a 1-hour fire resistance rating and an acoustics performance of STC and IIC of 50. How do I do that with a 5-ply CLT floor panel? And what are the boundary conditions around that room that I need to achieve to meet those fire, acoustics, and structural requirements? So then we'll really kind of get in through the nuts and bolts of helping them, first you're going to go to NDS Chapter 16 and do this fire design like we talked about. And then you're going to turn to this document we've put together that is kind of a database of all of the acoustically tested mass timber assemblies. And this is how you check a CLT panel for floor vibration. We have some CAD and Revit details on our website to help them see and understand the connections at the ends of the beams, panels, and columns. So it's really helping them step by step along the way, just ease any burdens or challenges that may come up. So a lot of it is that one-on-one project support. And then we also have created a lot of resources like white papers, short videos, presentations, things like that on the WoodWorks website that people can also access that way.
It sounds pretty unique. It's made me want to think, are there other organizations or companies, nonprofits for other materials out there doing the same kind of support for steel or concrete but outside of organizations?
Yeah, there's some similar things. I don't know that any of them are exactly the same. Well, I know that none of them are exactly the same. I know that the AISC Steel Solution Center, I recall prior to my time with WoodWorks, a steel wall structure, and I reached out to, I don't remember the name of the organization, but I think there's a similar organization for cold form steel. So there's similar groups, but I do know that we've seen some really good success. So some other programs have kind of looked to us as a benchmark and started to do some things in a similar manner.
That's awesome. And I'm assuming as a nonprofit, you still have to build a project somehow, or I don't know how you're earning money on a project, but I'm assuming it's tied to whoever needs help. So
yeah, so we don't charge anything for the services that we provide. Our funding comes from the wood products manufacturers and from the softwood lumber board, and we don't charge anything for the service. We do in-person conferences and educational events, and we do host some now, but they're kind of smaller regional events. For those, we might charge a nominal fee, like $20 or something, just to kind of make sure that the people that register actually do show up, and we haven't bought food for 70 when only 20 people are there. But yeah, we're a nonprofit, so we're not charging for those services.
That's awesome. What an awesome resource. That's really cool. Has there been a favorite project that you've worked on, or something that's come across your desk that has gotten you excited?
I think that one of the things that I probably missed the most from my consulting days, working for a local engineering firm, was working on local projects and being able to follow those through from, when I was designing it in the office to going out and doing construction administration to living in the community where that building is being used. So just recently, I was involved in a local project here in Vermont that used mass timber. It's the first mass timber building in Vermont. So I was working with their engineer this capacity with the better part of 3.5 or 4 years. Project was delayed because of COVID and had some financing challenges. So just last week, there was the ribbon cutting for this project. Project's called Fairbanks Museum. And so that was really cool for me to be involved in the design process, from very early on, and to help the team, and then help through some construction questions that came up, and then being able to be there, on the ribbon cutting and participate in that process, was really cool for me. There's a lot of really cool tall projects like we talked about. Mm-hmm. Those are of interest to me for sure, but it's really the local ones that I think are the special ones.
That's awesome. Yeah, in Salt Lake, I see these apartments going up all over where they start with a couple layers of concrete and then go up from there with timber designs. So it seems to be growing in popularity. Well, Ricky, this has been awesome. Thank you for sharing your wisdom, your experience with mass timber. I think there's a lot of fun information in here for people that want to head this way. If anybody had any questions, additional questions, or they wanted to reach out to you, what's the best way to find you?
It's woodworks.org. You can find my contact information, as well as we have an awesome team of people around the country. So there's always somebody close by to wherever you are, your audience are. So you can contact us that way. I'm also personally quite active on LinkedIn, so you can just find me on LinkedIn that way. Happy to connect.
Okay, awesome. Ricky, thanks for doing this. Hope you have a great evening, and hopefully we connect in the future.
Awesome. Thanks so much. Great to talk with you.
All right. See ya.
Take care.